called the angle sum theorem. That's kind of what we're going to talk about all this whole section. Just talking about really important theorems that we're going to see and use throughout geometry, then involve triangles. And the first one is the angle sum theorem, which says that all the angles of a triangle will add up to 180 every single time. Every single time you have a triangle, the angles will always add to 180 degrees. No exceptions. If it's not adding to 180 degrees, then it can't be a triangle. Okay? So if we look at this diagram, we have this triangle here, A, B, and C. And this theorem says that if you take whatever angle A is and add it to whatever angle B is, and add it to whatever angle C is, add up all three of those angles, it will equal 180. Okay? So just like we talked about with all those other theorems from this unit, we have to talk about why is this true? Okay? Someone didn't sit down and look at every single triangle in the world and conclude that it adds to 180. That's impossible. Okay? They did some math. Okay? And when they discovered that all the angles of a triangle add to 180, this is the math that they did. Okay? So we're going to use this triangle up here in this diagram in the box. Okay? And we want to show that I'm going to label the angles just so it's easier than stating like angle ABC every time and then it gets confusing. So just label this one 1, 2, and 3. So we want to show that 1, 2, and 3, those angles add to 180. And that's what we want to show through this math. And this is what the person who discovered this did. Okay? So in this diagram, in that box, we can draw a line through the top of it, through point B. And that's what they did. They had a triangle. They're like, you know what? I'm going to draw this line through here. Right through the top. Okay. I'm just going to go down. Right through the top. And we're just going to label it X, Y. X, Y. That line. Okay, and then I'm going to write in angles, just, again, make it easier on ourselves. This is going to be angle 4, and that's going to be angle 5. So label those angles. Draw it in that line, and label those angles. Just like that. It's easier to say angle 1 and angle 2 than, you know, ABC and CBA. It gets confusing. So it's easier with these numbers. Okay? And we drew this line so that it's parallel to the bottom. That's important. Okay, that's what they did. I'm going to draw a line at the top so it's parallel to the bottom. Okay? Using the angle addition postulate we talked about at the beginning of this unit, before we talked about linear pair angles, we can say that 4 plus 1 plus 5 make up what angle? What's the angle right here that they make up? We'll name it X, B, Y, right? If we take these three angles, they create this angle right here, X, B, Y, using that angle addition postulate. Kind of like linear pair angles, but there's three of them. Okay? So they make angle X, B, Y. Okay? What type of angle is angle X, B, Y? What's the triple type of angle? That's a straight angle, right? So we know angle XBY is a straight angle. And someone said it, what do straight angles equal? They equal 180, right? So can't we say that the three of these angles also add to 180 degrees? Because they're making up a straight angle. Okay? So we can, essentially what we're doing is taking 180 and plugging it in for that angle. Okay? We get our new equation, measure of angle 4, plus the measure of angle 1, plus the measure of angle 5 equals 180. Okay? They're making a straight angle. Therefore, all three of them add to 180. So that's what that person noticed. They drew the line and said, oh, these three angles make a straight angle. Therefore, these angles add to 180 degrees. Okay? So they noticed. They also realized, hey, I drew this line so that it was parallel to the bottom. Okay? So we can say that angle 2 and angle 4 are congruent, and angle 3 and angle 5 are are congruent. Why? If we know, it might help if you extend this bottom line. We know this and this are parallel to each other. How can we say 2 and 4 are the same? What allows us to say that? What? Very good. Yeah, they're alternate interior angles. These are also alternate interior angles. These, sorry. I forgot to put my phone on silent. Same number. I don't know what it is. He's calling me. I don't know why. So, these are alternate interior angles. These are alternate interior angles, so we can say they're the same. Well, if they're the same, okay, if 4 plus 1 plus 5 add to 180, and 2 is the same thing as 4, and 3 is the same thing as 5, well, 1, 2, and 3, aren't they also going to add to 180 degrees? Yeah, okay, because 2 is, and let's fill in the sorry, because they're alternate interior, okay, and because 2 is the exact same thing as 4, the same measurement, they're congruent, and 3 is the exact same thing as 5, we can put them into the same equation. We can take 2 and write it where 4 is. We can take 3 and write it where 5 is because they're the same. We're allowed to do that. Okay? So then that finally gets us what we want. If we add all the inside angles together, we get 180 degrees. And it will work every time with any type of triangle because of those steps. Okay? Because no one drew that line parallel and recognized these 3 angles add to 180 degrees because they make a straight angle. Okay, because that top line was parallel, that means, well, these and these have to be the same, and that has to be the same. So that means, because these 2 bottom angles are the same as these 2 outside angles, they're also going to add to 180 degrees. And with angle 1. And that's why that works. Okay? Questions over there? That part might seem overwhelming right now. Just an informal explanation of why this stuff works and why I'm telling you this stuff. Okay? So right now, don't necessarily focus on the why. If you find it overwhelming, just focus on the steps. Okay? Just focus on the theorem. That all the angles of a triangle add to 180 degrees. Okay? So we take a look at example 1. It says, using the diagram below, find the value of x. And notice all my variables, all the info I've given for angles of a triangle. What do we know about all the angles of a triangle? Add to 180. So to figure out what x is, all we have to do, add all 3 angles up and set them equal to 180 degrees. And just solve for x. So we solve for x, combine your like terms. What do we get when we combine 88 and 24? What do we get when we do 88 plus across?
112.
Good. Oh, not equal, guys. Okay. And then our last step, move that 112 over, and 180 minus 112 is what? 68. What's a shortcut to this when it's just numbers and variables now? Yeah. You could just shortcut is in your calculator, just do 88 plus 24, and subtract that number from 180. That's totally fine if you do that. I just ask that you show me those steps on paper. Just so if you accidentally type 23 instead of 24, you don't miss all the points, because I don't know where that number came from. Okay. So yeah, you could have just added these up, subtract them from 180, or just did 180 minus 88 minus 24 in your calculator. And it still gives you the same answer. Whatever way works for you. Okay. And B, again, we want to find x, and I notice 1 given angles of a triangle. What did we just find out? What do all the angles of a triangle add up to? 180. So we do the same thing. We just add all 3 of those angles together, set them equal to 180. when we solve, combine our like terms. We combine our like terms when we get x plus x is 3x. And then negative 31 plus 43 is what? Equals 180. And then our last step, you just solve it like a normal equation. Move the 12 over. 180 minus 12 is what? 168. And then finally divide by 3. When we divide by 3, what is our final answer? What is it? Not too bad. Whenever you have angles in a triangle, remember, they add to 180 degrees. And use that to solve the problem. That's what a lot of geometry is you have to remember these theorems, these rules, to help you set up the problem. You have to remember what linear pair angles are and that they add to 180. You have to remember what vertical angles are, that they're equal. Okay? You have to remember what alternate interior angles are, and that's that they're equal. Okay? You have to remember all the angles of a triangle add to 180. So the hard part is remembering all this stuff. The easy part is to solve it. Okay? Questions over that? So look at example 2. It says using the diagram below, find the value of the missing angle measures. Okay? Well, what angle do we have to find first? Do I have an option? First? Yeah, we have to find one first. Can't really find 2 or 3. Okay? So let's find the measure of angle 1. How can we find the measure of angle 1? It's inside of a triangle. Okay? Good. Yeah, we have a triangle here. Here's our triangle. We're missing one of the angles, so subtract the other 2 angles from 180. So 43 minus 74. What do we get when we do 180 minus 43 minus 74? 63. So the measure of angle 1 is 63 degrees. I'm going to fill that in my diagram. Color coded. What's the measure of angle 2 without having to do any work? 63. How do we know it's 63, Brandon? Good. It's vertical to 1, and we know vertical angles are the same. So we know angle 2 is 63 without having to do any work. And then finally, what do we have to do to figure out what angle 3 is? Yeah, combine those, subtract them from 180. So we get the measure of angle 3, or you can just subtract them right away from 180. And when we subtract those guys from 180, what do we get? 38. There we go. And we're done. Fill it in. It's super important to fill in your diagram. It's use a visual. Sometimes if you don't fill our diagram, it's hard to see what's going on. Questions over that? I like these kind of problems. They're little puzzles. Trying to find those missing pieces. Okay, questions over angle sum theorem. Okay. Flip it over. We're going to talk about another really important triangle theorem. That's important in geometry. And it involves isosceles triangles. What does it mean to be an isosceles triangle? Yeah, only 2 of the sides are the same. So if we have an isosceles triangle, if 2 sides of a triangle are congruent, that means the angles across those sides, the angles opposite of those sides, are also going to be congruent. And that's true every single time you have an isosceles triangle. So we look at this diagram. For example, if AB and CD are congruent, if those sides are congruent, then the angles across from those sides are also going to be congruent. So if we start at AB and go across, we get angle C. Start at CB, go across, we get angle A. That means angle A and angle C are congruent to each other. Okay? So we can use this now to solve problems involving triangles. The converse of this, converse just means like reverse order, switch. Okay? The converse of isosceles triangle theorem states that if two angles are congruent, then those sides across from those angles are congruent. It just switches the angles and the sides. Okay? So, for example, if A and C are congruent, then the sides across from those angles are also congruent. So then AB and CD are the same. I just switched it. Questions? Yes.
So it means like the angles across from C, so like AB would be equal to C.
So this means that AB and BC are the same. So let's say they're both 5. Okay? That means the angles across from them are the same measurement. So it might be that, like, this is 70 and that's 7. That's what that means. So, yeah, angles and sides can't be the same. So this is 5, it doesn't mean C is 5. It just means that these two are the same, and those two are the same. Other questions? Okay. Let's apply this. So take a look at these examples. It says find the values of x in each of the following diagrams below. So we take a look at A. We want to find x. I notice they're angles of a triangle. And what do we know about all the angles of a triangle? What do they add up to? 180. Can we use that? Can we use the angle sum theorem here to find x? Let's know maybe so. Can we use that? Can we do it on the front to find x on this problem? How come? Yeah, we have no idea, absolutely no idea what this angle up here is. None. So we can't do that. You have to know something about whether it's a variable or a number or a measurement. Okay, you have to know something about all 3 angles. We only know things about 2 angles. But what do we notice about 2 sides in this triangle? They're the same. And we just learned that the angles across from those sides are also going to be what? The same. So I know this angle, because it's across from this tick mark, and this angle, because it's across from the other tick mark, are the same. Well, if these 2 angles are the same, then what can we do to find x? They're equal to each other. Very good. So we can say 2x minus 27. What is that? X plus, is it 51? 50. Covered up with my art. We can set them equal to each other. So sometimes it might look like an angle sum theorem, but we can't. We don't know the third angle. Okay? But if you notice, it's an isosceles triangle, so those sides are going to be the same. And then solve it like a normal equation. Move the x over. We get x minus 27 equals 53. Add the 27 over. 53 plus 27 is what? X equals 8. Gosh. We take a look at B. B is a little different. What were we given this time around? Were we given sides or were we given angles? Sides, right? That's a little different. We don't really know about anything special about sides of a triangle. We don't add anything in particular every time. Okay? So we can't add them to 180. But what do we notice about 2 angles in that triangle? They're the same, right? So then what do we know about those sides across from the angles? They're also the same, using the converse of that theorem. The angle S, put a tick mark, go to angle T, put a tick mark. So what can we do with those sides? A little hint, if you're given sides in a problem, you're like, I have no idea what I do here. It happens in math, it's okay. Set them equal. That's all you can do with sides. Angles, you can do a ton of things. You can add them together, set them equal to 180. Set them equal to 90. Set them equal to each other. Subtract them from something. There's so many things you can do with angles. Sides, only really set them equal to each other. Okay, so if all else fails, you're dealing with segments, you're dealing with sides, you have no idea how to solve the problem, that's okay. Sometimes that does happen. Just set them equal to each other.
that only with triangles?
Any line. So, like, if you have a rectangle, or if you have something like that, and all failed, set them equal to each other. That's probably the only thing you can do. Just a helpful hint, if you're stuck. Now, don't fall on that every single time. Rely on that, but it's just a helpful hint in geometry. If you're stuck with sides, set them equal. They're more than likely to stay up. Angles, again, you can do a million other things with angles. But sides, really the only thing you can do is set them equal. But make sure you know why you're setting them equal. Again, in this case, they're across from angles that are equal. That means they're the same. And then solve. Move the 2x over. 6 is equal to x minus 6. Add the 6 over, so x ends up equaling what? What? So example 5 says, in the diagram below, find the value of x. Okay, I know one of my angles. I'm going to get this diagram. What's the measure of this angle right here with the little box? Good. We got a box. We know it's 90. I know this angle right here, 2x plus 3. What's the issue here? Do we know this angle?
No.
No. But Trent, what do we know about this triangle? Yeah, it's an isosceles triangle. Good. So what do we know about the angles across from those sides? They're the same. So 2x plus 3 is across from a tick mark. That other angle we don't know anything about is also across from a tick mark, so that means they're the same. Well, if we know they're the same, then one of the angles is 2x plus 3. What does the other angle also have to be? 2x plus 3. Okay. Here's the thing. This problem, we have an isosceles triangle, we set the angles equal to each other, right? Does it make sense to set these equal to each other? What's going to happen if you do? Yeah, everything is going to cancel out because it's the same exact thing. So that method doesn't work here. But what do we all know about all the angles of a triangle? Okay, add to 180. We have to do that here. We know add all three of those angles up. 2x plus 3, 2x plus 3, and 90. Set it equal to 180. Sometimes you're going to do what we did in example 4a. Set the base angles equal to each other, the angles across from the congruent sides. Sometimes you're incorporating both that isosceles triangle theorem and angle sum theorem in one problem. And then solve. Combine your like terms. What do we get when we combine our like terms? We get 4x plus 96. And then solve it like a normal equation. Move that 96 over. 180 minus 96 is what? 4. Divide by 4. We divide by 4. X ends up equaling what? What's equal? Go on. Just be aware of that. Sometimes you need to know the isosceles triangle theorem and then use the angle sum theorem in here. But two things in one. Okay? Because we know the angle sum theorem and now we know the isosceles triangle theorem, we can get this thing called a corollary. The corollary is kind of like a postulate, except you get the info, the fact that requires a little proof, because you did other things. You proved other facts, which led to this kind of no-brainer fact. Okay? That's kind of what a corollary is. And the first one is what we talked about before, Unit 1. A triangle is equilateral. Oh, if and only if it's also equiangular. Vice versa. If it's equilateral, it's automatically equiangular. If it's equiangular, it's automatically equilateral. Okay? Meaning, what does equilateral mean? All the sides are the same. Equiangular means Figure what your butt's out. Okay? Good. Well, we also know, a new one, is that each angle of an equilateral triangle must have a measure of 60 degrees. Because we just found out an equilateral triangle, all the angles are the same. And all the angles have to add up to 180, right? So they all have to be, 180 has to be divided up equally between those three angles. So they all have to equal 60, right? Because we look at an equilateral triangle, okay? All three sides are the same, and they're all crossed with the same number of tick marks, so that means that they're all going to be the same. Three angles that are the same, they all add to 180. 180 divided by 3 is 60. Okay? So they're all going to equal 60 degrees. So another important thing to know. Okay. Equilateral triangles, all their angles are 60 degrees. So in this last example, for each diagram below, find the value of the missing variables. Okay? What kind of triangle in A? What kind of triangle do we have? Equilateral. What did we just talk about? What do all the angles of an equilateral triangle equal? 60. These are all 60 degrees. And I know one of my angles is 6x. How can we set up an equation to solve? 50?
Well, you just know that 6 times 10 is...
Yeah, we know this angle right here, 6x. We know it's an equilateral triangle, so we know it's going to be equal to 60. And then you just solve for x. Divide by 6. And 60 divided by 6 is 10. Okay. We know this angle is 60. We know it's also 6x. So set it equal to 60. If you're stuck, if you forget that little fun fact, you would have just added 6x 3 times. Because if all the angles are equal, they're all going to be 6x. You know, that plus that equals 180. And you still would have gotten 10. It's just a little more work than just setting it equal to 60. We're not done. Should we back it up? I don't know. Still 5 minutes. So we take a look at B. What do you notice here? What type of triangle do we have? It's equilateral. What do we know about all the angles? Equal to 60. Okay? So this angle right here, 60. This angle right here is 60. And this angle right here, 60. What do we know about this entire angle on the bottom because there's a box? 90. So if this little part right here is 60, what's the rest of it have to be? 30. So I'm going to fill that in. I know this is 30. So this whole thing's 90. Part of that 90 degree angle 60, so the rest of it has to be 30. Does that make sense? Okay. Well, what kind of triangle? What kind of triangle do we have here? Isosceles, right? And we know the angles that cross from the sides that are the same are also what? The same. So if this angle right here is 30, what's x have to also be? 30. I did this in the last class too. I wrote it out there. Right? So I know this is 30. I'm going to label it. Well, what do we have to do to find y? Yeah, subtract 30 and 30 from 180. We are not done. I should not be hearing anyone back up. I still have you for 3 minutes. We're going to keep working for 3 minutes. What's 180 minus 30 minus 30? 120. So that is the measure of y. Back it up doesn't get you out the door.